Right now, picture your screen showing a pile of dull, lifeless stones, rough surfaces, faded colors, some gray, others whitish, some stained with rust. Nothing about them looks worth a second glance. They're the kind of rocks most people would kick aside on a hiking trail or toss away while sifting through river gravel. But here's the revelation that can completely change the way you see the mineral world. Many of these ugly, opaque, and seemingly worthless rocks are actually hiding some of the most valuable minerals on Earth. I'm talking about rubies and sapphires. That's right, the same gems that shine in jewelry worth thousands of dollars almost always appear in nature as irregular crystals mixed with ordinary rock. If you expect to pick up a ready-to-wear jewel straight out of the gravel, forget it. The first step is learning to recognize these crystals in their raw state, still trapped inside their host rock or rolled by erosion into a riverbed. And you might be asking yourself, how can a ruby or a sapphire possibly look like nothing more than a worthless rock? The answer is geology. Both belong to the corundum family, minerals that form under extreme pressure and heat, usually inside metamorphic rocks like gneiss, schist, and marble. In many cases, the crystal doesn't form perfectly. It stays embedded in the rock, covered with rough edges and mineral inclusions that hide its shine. Only after cutting and polishing does the deep color and transparency reveal their true beauty. This is where most people make a mistake. They see a dull pebble, no glassy sparkle, and assume it's worthless. They throw it aside, but an experienced gem hunter knows that these deceptive signs may actually hide something precious. Sometimes just a natural fracture or a slight polish is enough to reveal the deep red of a ruby or the intense blue that makes corundum a sapphire. And that's exactly what we're going to explore in this video. How not to fall into the same trap that makes so many people overlook valuable stones. Along the way, you'll learn to recognize the types of rocks that serve as nurseries for corundum, the indicator minerals that act as clues, and the visual signs that separate a rough ruby or sapphire from a simple piece of quartz or granite. You'll see, for example, why twisted bands in a gneiss can hide sapphire crystals between its layers. You'll understand how fragile-looking schist can actually be the perfect environment for ruby growth. And you'll learn why raw, dull marble has revealed some of the purest rubies ever discovered. And we won't stop at theory. We'll also cover secondary deposits, places where erosion carried corundum away from its original host rock. Rivers, gravels, and sandbanks act like natural sorting machines, separating lighter minerals from heavier ones. That's where rubies and sapphires may appear as small, rounded pebbles, polished by water, waiting to be spotted by anyone who knows what to look for. So stay with me until the end of this video, because if today you still see ordinary rocks as worthless, after this explanation, you'll never look at soil, river gravel, or a rocky cliff the same way again. The knowledge you'll gain here is what separates those who spend a lifetime stepping over gems without noticing, from those who recognize the signs and transform an ugly stone into a true discovery. And the promise is clear. By the time we're done, you'll know how to identify the main rock types and the visual clues that reveal the presence of raw rubies and sapphires. This knowledge could change the way you hunt for gems, and it might just be the first step toward a discovery hiding right under your feet. In the introduction, we saw how ugly rocks can sometimes hide treasures. Now it's time to understand exactly what those treasures are. Both rubies and sapphires come from the same mineral, corundum. The name may sound technical, but it's the key to why these gems are so valuable. Corundum is crystallized aluminum oxide. By itself, it would be colorless or slightly gray. But what makes all the difference are the trace elements that sneak into the crystal structure during its formation. These foreign atoms replace some of the aluminum and completely change how the crystal interacts with light. That tiny adjustment is what creates the vibrant colors we know. When corundum contains chromium, it turns red. And if the saturation is strong, that vivid deep red, we have a ruby. No other gemstone replicates this exact tone. It looks almost internal, as if the crystal were glowing from within. This effect is so striking that rubies have symbolized power and vitality since ancient times. But what really matters for us is knowing that this red is not superficial. It's part of the crystal itself, and it can be hidden under rough rock surfaces. When corundum contains other elements like iron and titanium, the result changes. The most common combination produces blue, which transforms the mineral into a sapphire. But here's something most people don't know. Every corundum that isn't red is called sapphire. That means sapphires exist in many colors: blue, pink, yellow, green, even colorless. On the market, the most prized is still the deep royal blue sapphire, especially the ones with a uniform tone like the legendary cashmere blue. This classification may sound simple, but it's essential when you're identifying stones in the field. If corundum shows any shade of red, even small or irregular, it's a ruby. Any other color, blue or otherwise, is sapphire. This logic helps avoid common mistakes, like confusing yellow sapphire with citrine or mistaking a pale ruby for garnet. Beyond color, one feature places corundum among the top gemstones: hardness. On the Mohs scale, which ranges from 1 to 10, corundum ranks 9, second only to diamond at 10. That means a raw ruby or sapphire can scratch almost any other mineral you might find in nature. One of the simplest field tests is the glass test. If your stone scratches ordinary glass, there's a good chance it's corundum. Another key characteristic is luster. Polished corundum shines with a vitreous to adamantine glow. But in its raw state, that shine is often hidden. Surfaces can be worn, coated with mineral crusts, or look cloudy. That's why so many people walk right past rubies and sapphires without realizing it. Carried by rivers or locked inside metamorphic rocks, corundum often looks like an ordinary pebble. Only a trained eye notices that subtle reflection that persists even in the shade, a quiet clue that the stone is different. And rubies and sapphires rarely appear alone. They're often found alongside indicator minerals like mica, feldspar, garnet, or ilmenite. Spotting these companions is a strong sign that you're in the right geological environment. Why then is corundum both resistant and rare? Because it forms under extreme conditions, very high pressures and temperatures, usually where tectonic plates collide and crush rocks together over millions of years. That's why most ruby and sapphire deposits are tied to metamorphic belts, or to rivers that carried the crystals away from those environments. So to sum it up, rubies and sapphires are not two different minerals. They are the same substance, corundum, distinguished only by trace elements. Chromium gives us ruby red. Iron and titanium give us sapphire blue and other colors. Both rank 9 on the Mohs hardness scale. Both have a vitreous luster, and both command high prices. But in the field, they almost always appear as dull, irregular, unimpressive stones. And that's the real secret. The gem hunter who learns to recognize raw corundum will never dismiss an ugly rock, because they know it might just be hiding one of the most coveted gemstones on Earth. Now that you understand what rubies and sapphires really are, we need to answer the practical question: where exactly do these crystals appear in nature? The answer isn't just any rock, but very specific types of rocks that act as the perfect nurseries for corundum. The three most important are gneiss, schist, and metamorphic marble. What they all have in common is their origin. These rocks are the product of deep transformations in environments of extreme pressure and heat. This process, called metamorphism, occurs when pre-existing rocks recrystallize and change their internal structure. And it's in this exact setting that aluminum and oxygen combine to form corundum. If elements like chromium, iron, or titanium are present at the same time, they add color to the crystals, turning them into rubies or sapphires. But how can you identify these nurseries in the field? Let's take it step by step. Gneiss is a coarse-grained metamorphic rock formed from granite or similar rocks that went through intense metamorphism. Its most striking feature is the parallel banding, which looks like twisted or folded stripes. These layers form because minerals reorganize under pressure, creating alternating light and dark zones. For a gem hunter, this is a signal worth noting. Within these recrystallized bands, corundum crystals can appear, often hidden between the stripes. At first glance, gneiss looks like nothing more than a heavy, dull block, but with careful observation, You may spot faint bluish or reddish stains, hints of sapphires and rubies in raw form. Schist is even more common as a host rock for corundum. It forms from shales or mudstones that were subjected to medium to high-grade metamorphism. Its main feature is foliation. It splits into thin sheets, almost like pages of a stone book. Many schists also show a faint metallic shimmer caused by minerals like mica and chlorite. This shine often misleads beginners, who assume it's just a fragile, worthless rock. But it's precisely along these foliation planes that rubies and sapphires find room to grow. The contrast is fascinating. On one side, a rock that looks weak and crumbly. On the other, one of the hardest minerals on Earth. A useful detail is that corundum crystals and schist are often found together with mica, garnet, and feldspar. If you see those minerals in the same place, your chances of being in the right spot increase dramatically. Metamorphic marble. Finally, there's marble in its raw form, very different from the polished marble used in floors or sculptures. Metamorphic marble is the result of limestone transformed by heat and pressure. It's usually opaque, white, beige, or gray, without shine. It often shows gray or yellowish stains and has a granular texture, almost like coarse sugar. This is the environment that produced some of the world's most famous rubies, like those from Burma, now Myanmar. The reason is simple. Marble has very low silica content, which prevents many other minerals from forming. This allows corundum to grow with greater purity and fewer inclusions, resulting in rubies of exceptional quality. For gem hunters, recognizing raw marble is crucial. At first glance, it may look like an unremarkable rock, but a closer look can reveal reddish or pinkish spots, the telltale sign of rubies embedded inside. Field summary for gem hunters. Nice. Look for twisted, parallel bands and faint-colored stains. Schist. Check for thin foliation layers and weak metallic shine. Confirm with companion minerals. Raw marble. Identify the granular, opaque, light-colored texture. Search for reddish or bluish stains. These three rocks may not look attractive, but they are the main environments where rubies and sapphires develop. Knowing how to recognize them is a decisive step, because the real secret isn't looking for stones that already sparkle, it's understanding which rocks might be hiding corundum crystals. And when you combine that knowledge with practice in the field, your chances of finding a gem that most people would overlook increase dramatically. So far, we've talked about the host rocks where rubies and sapphires are born, but the truth is, you don't always need to break apart blocks of gneiss, schist, or marble to find corundum crystals. Many times, nature has already done this hard work for you. That's where secondary deposits come in, places where erosion, rivers, and even glaciers have concentrated gemstones over thousands or even millions of years. The process begins high in the mountains at what we call source rocks. Rain, ice, and temperature changes gradually break down the metamorphic rocks that contain rubies and sapphires. Over time, corundum crystals are freed. Because they are extremely hard and resistant, they survive this natural wear and tear that would destroy weaker minerals. Once released, they are carried downhill by gravity and water, eventually reaching rivers and streams. Inside rivers, an important phenomenon takes place: the natural separation of minerals by density. Quartz and feldspar, for example, are lighter and easily carried away by the current. Corundum, being denser, tends to settle where the water flow slows down. These areas are known as trap points. And where exactly are these trap points? River bends. When the water makes a sharp curve, the inner part of the bend has slower flow. That's where heavy minerals collect. Behind large rocks or logs, any natural obstacle reduces water speed, creating calm zones where dense stones can settle. Deep pools, near waterfalls or narrow channels, swirling currents act like natural sieves, concentrating heavy minerals at the bottom. That's why experienced gem hunters rarely dig at random. They know the best spots for panning aren't shallow, open stretches of a river, but these strategic points where nature has concentrated crystals over time. And this process doesn't happen only in rivers. Glaciers have also played an important role in some regions. During the last ice age, massive sheets of ice scraped entire mountain ranges, carrying away chunks of rock for hundreds of miles. When those glaciers melted, They left behind mixed sediments and minerals known as glacial till. In countries like Canada, rubies and sapphires are still found in these deposits, preserved almost untouched. Now let's look at some practical examples in the United States. Montana is one of the most famous sapphire locations. They've been found in alluvial deposits along the Missouri River and in areas like Rock Creek. These crystals often show a wide range of colors, bluish-gray, greenish, or even colorless in their raw form. Many only reveal vibrant colors after cutting or heat treatment. For the gem hunter, the key detail is that they appear in river gravels, mixed with rounded quartz and ordinary pebbles. Knowing how to spot their density and subtle luster makes all the difference. In North Carolina, especially around Franklin, rubies and sapphires are found in gravels brought by local rivers. There, amateur hunters and tourists use simple screens to separate crystals from sediment. It's not uncommon to find small pinkish rubies or bluish sapphires among stones that look worthless. This is a classic example of how secondary deposits make gemstones accessible even to beginners who don't work with primary rock deposits. The most interesting part is that these two examples, Montana and North Carolina, show how completely different environments can produce the same result. By now, you already know that rubies and sapphires are corundum crystals, that they develop inside metamorphic rocks like gneiss, schist, and marble, and that erosion can transport them into rivers and secondary deposits. But this raises a practical question. How do you tell a raw corundum crystal apart from an ordinary stone in the field? This is where a trained eye makes all the difference. The first detail to watch for is luster. Many stones shine under direct sunlight but lose all their glow in the shade. Corundum is different. Even without strong light, it keeps a persistent, glassy reflection that sets it apart from common quartz or feldspar pebbles. That consistent shine, even in diffuse light, is one of the most reliable signals to pay attention to. The second detail is crystal structure. When corundum crystals have room to grow, they often form hexagonal shapes. In larger samples, you may notice six-sided prisms or terminations that look like flattened pyramids. Many times these forms are partly hidden in the surrounding rock, but even a single well-defined hexagonal face is a strong clue that you may be looking at ruby or sapphire. Another useful characteristic is density. Corundum is heavier than most common river stones, especially compared to quartz. When you hold two pebbles of similar size, one quartz and one corundum, the difference in weight is clear. This simple test is extremely practical when you're examining rounded crystals that have been worn smooth by river transport. Next comes hardness. Corundum sits at 9 on the Mohs scale, just below diamond. That means it can scratch nearly any other mineral you encounter in the field. A quick way to check is the glass test. A rough ruby or sapphire should scratch ordinary glass with ease, while softer minerals will leave no mark. This doesn't replace a lab analysis, but in the field it's one of the most reliable ways to separate common stones from possible gems. Finally, pay attention to companion minerals. Rubies and sapphires rarely occur in isolation. They are often found with indicator minerals that act as valuable clues. These include mica, with its metallic sheen and sheet-like flakes, feldspar, which shows up as light, opaque blocks, often mistaken for quartz, and garnets, which usually appear as small, rounded red or brown crystals in the host rock. Finding these minerals together is a strong sign that the geological environment is favorable for corundum. The key point is that no single sign is enough on its own. A heavy pebble might just be basalt. A glassy shine might come from quartz. But when all the signs come together, persistent luster, high density, hexagonal structure, ability to scratch glass, and the presence of indicator minerals, the probability that you're looking at ruby or sapphire increases dramatically. Now that we know how to recognize rubies and sapphires in the field, it's time to look at real cases. After all, nothing reinforces what you've learned better than true examples of stones that looked worthless, but after being cut, turned into gems fit for fine jewelry. Let's start with Canada, a country few people associate with rubies and sapphires, yet one that holds fascinating deposits. In the Yukon, one of the most studied areas, sapphires appear in alluvial deposits formed by the melting of ancient glaciers. These crystals traveled for miles inside gravels carried by meltwater. In the field, what you see are small, rounded pebbles, bluish or greenish, often with a dull, opaque look. At first glance, they look like nothing more than milky quartz or volcanic glass. But on closer inspection, they reveal higher density, persistent luster, and sometimes even hexagonal faces. Once cut, these crystals have been transformed into transparent, high-quality sapphires that sold for over $1,000 per carat. Farther east on Baffin Island in Nunavut, the discoveries are different. There, rubies and sapphires appear embedded in ancient metamorphic rocks, such as gneiss and marble. These crystals are more angular, often with intense color, but covered by mineral crusts that make them look dirty and lifeless. There are accounts of collectors who ignored rocks with reddish stains and raw marble, assuming they had no value. Only after cutting in a lab did they reveal rubies with surprising purity. Even small specimens were valued in the hundreds of dollars, simply because they showed the right color and good transparency. Now crossing the border into the United States, we find two of the most famous cases. In North Carolina, especially around Franklin, local rivers concentrate rubies and sapphires in gravels that even amateur hunters can access. Visitors can rent simple screens and, with patience, find rolled crystals mixed with quartz and feldspar. Many of these pebbles look unimpressive, pale red, almost pink or bluish-gray, opaque and cloudy. Yet after cutting and polishing, they reveal themselves as vibrant gems. Some rubies from this region, even modest in size, have sold for thousands of dollars, especially when they show that saturated tone known as pigeon's blood. Another remarkable example comes from Montana, more precisely, the Rock Creek region. Montana sapphires are known worldwide, but in raw form they often go unnoticed. They usually appear as rounded crystals with faded bluish, greenish, or even yellow tones, with little resemblance to the jewels you see in store windows. However, once cut, many reveal vivid colors and remarkable transparency. There are stories of Rock Creek sapphires, originally ignored by inexperienced hunters, that after cutting reach values of $5,000 to $10,000 per stone, depending on their color and clarity. These real-world cases highlight an essential truth. It's not the raw size that determines value, but the quality after cutting. A corundum crystal the size of a fingernail, if it has strong color and few inclusions, can be worth more than a larger stone that's pale or fractured. The common beginner's mistake is to dismiss small or dirty-looking crystals, when in fact they may be hiding the potential to become extremely valuable gems. Now imagine that, after watching this episode, you decide to explore a river gravel bed near your town, or even that stone path you cross every day without giving it much thought. Among the ordinary pebbles, suddenly you spot an opaque stone, heavier than it looks, with a reddish or bluish hue that doesn't fade in the shade. Your first thought comes quickly. Did I just find a ruby? Or is it just a piece of quartz stained with iron? It's in this exact moment that the doubt is worth more than the stone itself. Many viewers of this channel have written to say they found unusual crystals, but hesitated to test them, afraid of breaking them or lowering their value. Others sold them for just a few dollars, not realizing they had corundum in their hands that could have been worth thousands. And here lies the big lesson. Finding the stone is only half the journey. The real value is in knowing how to recognize what you found. Hardness, density, luster, and crystal shape. These are simple tests you can do at home without a lab. This practical knowledge is what turns an ignored pebble into a true discovery. Now think about this. If rubies and sapphires are hiding in rocks that look completely ordinary, how many other gemstones might be going unnoticed under our feet? That ugly rock you'd normally kick aside could actually be the key to finding minerals even rarer and more valuable. That's why we created the guide Gemology Journey for Beginners, a practical manual with comparison images, basic tests, and straightforward instructions for anyone starting out as a gem hunter. It's the tool that keeps a ruby from ending up in a drawer mistaken for glass or quartz. But if now isn't the right time for you to get the guide or become a member, that's no problem at all. You can still stay subscribed to the channel and follow every video for free. In fact, in the next episode, we'll reveal how to recognize emeralds hidden inside common rocks. One more step in this journey of transforming the way you see the mineral world. So remember, the next stone you almost kick aside might just be your greatest discovery. Good luck, gem hunter!